So this lecture we're going to talk about our last little term for this section, and this is isoelectronic. So let's say, well, what does isoelectronic mean? So we've got the word iso and then electronic. We've been talking about electron configurations this whole time. So you kind of see the word electron here, so you should kind of be thinking it's related to these electron configurations. So something is isoelectronic if the particles with exactly the same electron configurations. So this would be something that's isoelectronic. So in my example, I'm saying that these guys are isoelectronic. I'm saying that they all have the same electron configurations. So what we can do is we can check it. Let's say, how do we actually know that these all have the same electron configurations? So let's write them all out. Good way to practice. So let's pull up our periodic table. So the first one was neon. So if I need the electron configuration for neon, it's a noble gas, so it's just itself. All right, the next one was Na+. So if I want Na+, I have to do Na. So let me find Na, here's Na. So the noble gas is gonna be up and over, so it'll be number 10 over there, neon. And then it'll be 3s1. So to get Na+, I need to remove one electron from the outside. This is my only choice on the outside, and he only has one. So I just take the whole thing away, and I get neon. So now we see that neon and Na+, these two were isoelectronic from each other. So these were the ones that were on my list. So if we go back, I'm just doing the ones on the list. Neon and Na+, they had the same electron configuration. All right, what was the next one? The next one was Mg2+. So to do Mg2+, I need to do Mg. So here's Mg. So if I go up and over, my noble gas is neon. And then I'm here, I'm in the 3s1, 2. So now I have the neutral, so I want Mg2+. So it's a cation, so I remove 2 electrons. I have these 2 electrons on the outside, so I remove them, and all I have left is neon, which is what I expect since I said they're isoelectronic. All right, so now let's move to our anion. So the next one was F-. So if I want F-, I have to do F. So let's find F. Here's F. So his noble gas is going to be helium. And then I come over here and I've got 2s2. Then come over here, I'm still in the P, I'm in the P, and I'm still in the 2, so 2p, 1, 2, 3, 4, 5. 2p5. All right, if I'm an anion and I'm a -1 anion, that means I add 1. So just add 1 to the next section. So if I'm in 2p5, I know I can have up to 6, so I can put 1 more in there and he'd be okay with it. So helium 2s2, 2p6. Now you might say, wait, I thought we were trying to get them all to be neon. Remember, we can rewrite this. Helium 2s2, 2p6 is the same thing as saying neon. So remember, we said we could also write this guy as neon. All right, our last one was O2-. So if I want to do O2-, I got to do O. So here's oxygen, noble gas is helium. And then I come over here, 2s2. And then over here, 2p, 1, 2, 3, and 4. So that's the neutral. If I want the -2 anion, I'm going to add 2 electrons. So the last one I wrote was my P. He can have up to 6. I have only 4, so I can put these 2 extra in here. So I go ahead and do that. I get helium 2s2 2p6. And remember, we can rewrite that. If it's helium 2s2 2p6, 1, 2, 3, 4, 5, 6, it's the same thing as neon. Alright, so isoelectronic means that each one of these guys, my neon, my sodium plus, my magnesium 2 plus, fluorine minus, and oxygen 2 minus all have the exact same electron configurations. So remember, that's the definition of isoelectronic. All these guys have the same electron configuration. Alright, so that is the end of our discussion on electron configurations.